Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. I will write your name in my mathematics log. If you ever have a blank space, you fill that blank space with mathematics, of course. Let's get back to it, shall we? We learned but we learned about the equations of planes in vector form, Cartesian form. And we're going to use those to solve a couple of fairly simple problems. So here we go. We are tasked with finding the equation of the plane with the normal vector 1, 2, 3, and which contains the point -1, 2, 4. So from our formula sheet and from what we've learned, I'm going to go with the Cartesian equation of a plane. And I'm going to write it out like this: ax plus by plus cz is equal to the constant d, but I just want to remind you that that constant d comes from a known point on the plane. Okay? This x, y, and z represents all points on the plane, and this is a known point on the plane. So we can easily solve this, ax plus by plus z, or come up with the equation by replacing a, b, and c with 1, 2, and 3. So this would be 1 times x, or x, plus 2 times y is 2y, plus 3 times z is 3z. And that is going to equal the same coefficients, so 1 times the point that we know, our x, y, and z coordinates, so 1 times -1, plus 2 times 2, plus 4 times 3. I feel like I missed something. No, there's the negative. Okay, so that becomes x plus 2y plus 3z is equal to, what does that come to? 15. And there you have it. Okay, so next up, find the equation of the plane through these 3 points. And if you think about it, hopefully you know this, through any 3 points there is at least one plane, and there's an infinite number of planes through collinear points. Okay, that's why I said at least through any 3 points. All right, so let's find it in vector form. So here's how we're going to do it. First, we're going to find a vector, and using these points, I'm going to go with vector AB. Okay, and vector AB is equal to, without going into the mechanics, 4, -1, 1. And I'm also going to find vector CB. Okay, and vector CB is equal to 2, 1, -2. Those are 2 vectors that are parallel to the plane because they are in the plane. And I'm going to choose to use C as my fixed point. I could use any of them. It really doesn't matter. So using C, I have R is equal to, and I'm being overly cautious here, X, Y, Z. I'm just putting, just so we understand exactly what's happening here. And so since C is the fixed point, that's going to be 1, 0, 3, plus lambda times 4, -1, 1, plus mu times 2, 1, -2. And it's understood, but we can still write if we want to, that lambda and mu are real numbers. Okay? So that's part A. So now I have to find it in Cartesian form. Okay? So let's go the normal vector route. So if n is the normal, yes, then I know that it is equal to the cross product of vector AB and vector AC. Yes? Okay. So that would be equal to 4, -1, 1 times, or cross, I should say, 2, -2, 3. Okay. So remember how to find your cross product. That would be equal to ijk. And then that's going to be my x components, so 4, 2. My y's, -1, -2. And then 1, 3. And that equals -1, 1, -2, 3i. Right? Remember that? So I eliminate the I row and I use what's left. Minus, and this is in your formula packet as well. So this would be 4, 2, right? 4, 2, 1, 3, j, plus 4, 2, -1, 2. Okay? So that would equal -1 times 3. Let's see, minus -2 times 1 just gives me a -1, right? Yeah, because that's -3 plus 2. So that would be -I, and I'm not going to go through the mechanics to save some time here. Minus 10j, using the same process, 12 minus 2, plus, what do we got? Oh no, it's minus, sorry. Minus 6k. Okay, so what does that tell us? Well, I can write this as -1, -10, -6, or that's equivalent to -1, 10, 6. Okay, so how does that help me? Once I have my normal, I can easily do my Cartesian because I have my A, my B, and my C. So that means that I have 1x, which is x, plus 10y, plus 6z, so popular. And that is equal to, and now I'm going to use my coefficients, and I would have -1 plus 10 times 2 plus 6 times 0. And where am I getting these? Well, I just use point A right there, right? -1 times 1, 10 times 2, 6 times 0. So I end up with x plus 10y plus 6z is equal to 19. Okay, and that'll do it for now. We'll make one more short one with a couple of more examples. We'll go out with T Swift, see how she's doing. And I am out.